Welcome to Math with Ras, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, you're in the right place. Let's dive into today's lesson, and please don't forget to subscribe for more videos. Now, today our lesson is going to be based on the synthetic method of division of polynomials. Synthetic method. So in our previous videos, we talked about how to divide polynomials, of which we said we have two ways or two methods that can help us to do that. Of which we talk about the long division and the synthetic method. Today our focus is going to be on the synthetic method of division of polynomials. Generally, this strategy can help us to deduce or get the quotient and the remainder of a polynomial divided by a linear factor. Alright, so let's dive into how to deal with this type of strategy. Generally, to do with this, the polynomial given first, you need to list the coefficient. List the coefficient and make sure that you include all missing or all the zeros or all missing terms. So you place it with what? 0. So for example, if it is x cubed plus, let's say 4x, what is the missing term here? We should have like something like x cubed plus, let's say 0x squared plus 4x. So the coefficient here should be what? 0. So you use 0 to replace that one. Now, always remember that the division, the divisor should be in the form x minus c, and our c is placed at the left side. Then we first bring down the first coefficient down. You multiply by c, then we add to each row. That's how we do it. So let's take a typical example and look at how it is being done. So our example 1, x cubed minus 2x squared minus 5x plus 6 divided by x minus 3. Then we have to divide this by this. Now remember, I said this one here, the divisor should be in the form x minus c. So it means that our term here, the c, can be what? What will be c? Okay. Now this can be written in the form x minus plus c, which is the same as x minus 3. So this is our c is what? Positive 3. Now this is how we do it. We are going to write our 3 at the left here. Then we write our coefficient from the polynomials. So the first one, coefficient is 1, second one is negative 2, third one is what? Negative 5, then we have 6. Okay, so we said that the first thing you need to do here is what? Bring down the first coefficient. So you bring it down. You use that one to multiply the c. What you get, you add it to this column. So you have 1 times 3, you get 3. Then you get negative 3, negative 2 plus 3, you get what? 1. Now, the next thing, you use the 1 to multiply the 3 here. So 1 times 3 will give you 3. Then you add negative 5 plus 3, you get negative 2. Now, the next step, Negative 2 times 3 will give you what? Negative 6. You add, you get 0. So the last digit here is the remainder. So this is the remainder. So anytime you divide and get a remainder to be 0, it means that this divisor here is a factor. It's a factor of the polynomial given. Yes, it's a factor of the polynomial given. Now, how do we write this? Let's take the first thing. We have x cubed. We divide by this. You get what? X. You get what? X squared. So it means our first term you what? X squared plus x in that order minus 2. Our remainder is 0. So this is the quotient after the division. Let's take another example on that. Take another example on that particular aspect. Okay. The next example, example 2. X cubed plus 5x squared plus 7 plus 2 divided by x plus 2. Now, how do we do this? Now, we said that we need to get our c. Now, this should be in the form x minus c. So meaning that this here can be written in the form x minus 2, right? Yes. So it means that our c is negative 2. Negative 2. Now let's write our coefficient from here. We have the first one being 1, second one 5. We are supposed to get okay, so this is supposed to be, this is the question, this is 7x. So we have our 7 being our next one, then we have the last one 2. So we bring down the first coefficient, we use to multiply the c. So 1 times negative 2 will give you what? Negative 2. Then you add. So 5 plus negative 2, this is going to be 5 minus 2. Then you get what? 3. Now 3 times negative 2 will give what? Negative 6. Then you add. This is going to give us what? 1. Now 1 times negative 2 will give a negative 2. Then you add, you get 0. So our remainder is 0. Okay, so once again, we have x cubed divided by x. This is going to be what? X squared. So our first thing will be what? X squared plus 3x plus 1. And this becomes what? The quotient. Yes, that becomes our quotient. Yes. So you see, this strategy is quite simple. All right. Now, let's look at a different form of this type or this strategy. Our example 3, we have 3x squared plus 7x minus 20 divided by x plus 5. Now, let's dive into this. So we have our in here. What will be our c? The c that we are going to write here, what will be it? Say that this should be in the form x minus c. So we have plus here. It means that it can be written in the form x minus what? 5. So it means that our c is what? Negative 5. So we can write our negative 5 here. Now let's go for our coefficient. The first one is 3. Second one is what? 7. Now the third one is what? Negative 20. Okay, so let's see. You bring down the first coefficient, then so if you bring it down, you multiply by the c, you get negative 15. Then you add, you get negative 8. Using negative 8 to multiply negative 5, you get what? 40. Then you add. So you just multiply, you add, you multiply, you add. And this is going to give us what? 20. Now in this case, our remainder is not 0. Yes, our remainder is not 0. So in this case, it tells you that this is not a factor of the polynomial. This one is not a factor. So what will you do here? Okay, so how will you write this? So remember the first term, we have 3x squared divided by x. If you take this, we are going to get what? 3x. So our first term here should be what? 3x. Then minus what? 8. Now, anytime you have a remainder in this form, you are going to write it divided by the divisor, which was the x plus 5. So this is how you are going to write it if the remainder is not 0. Yes, this is how you are going to write it if the remainder is not what? 0. Okay, so let's take another example on that. So example 4. Example 4. We have 7x cubed plus 6x minus 8 divided by x minus 4. Now we are going in for the synthetic method again. So what will be our c? So if you want to get the c, you said that it should be in the form x minus c. So it means that this can be in the form x minus positive c. So our our c should be 4. So we have 4 here. Then our coefficient here, we have the first one being 7. Second one, you see the missing term here should have given 0x squared, something like this. So the next one should be what? 0 followed by 6, then negative 8. Yes. So you bring down the first coefficient, you multiply by this, you get what? 28. You add, you get 28. 28 times 4, you get 112. You add, you get what? 118. 118 times 4 will give you what? You get 472. You add, you get 464. So in this case too, the remainder is not 0. So how are we going to write it? So we had our first term to be 7x cubed divided by x, we get what? 7x squared. So our first term here should be 7x squared. Then in that order, we get 28x plus 118 plus 464 divided by the divisor, which was x minus 4. And that is simple. It is quite simple. So thank you for watching. Welcome to Math with Russ, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, you're in the right place. Let's dive into today's lesson. But first, please don't forget to subscribe for more videos. Alright, so today our lesson is going to be based on the remainder theorem. The remainder theorem. Okay, what is the basic idea behind this? Let's say you have a function f of x divided by a linear factor x minus c. The remainder is equal to f of C, and this is basically just putting in C into the function straight to get that value. So if you put the values of C or C into the function, what you get becomes what? The remainder. Alright, so that is the basic idea of this. So let's take an example. Let's say you have a function f of x being equal to 2x cubed minus 5x squared plus 6x minus 12. You have to find f of 4. It basically means that you are going to substitute this 4 into the function. Yes, you are going to do what? Substitute that. Now this type 2, we can use the synthetic method to solve it. Yes, it's quite possible that way. So we have two ways. It's either we put in the values straight or we use a synthetic method. Remember, when we're doing the synthetic method, at the end we get a remainder. Yes, that's the remainder that we are talking about here. Okay, so first let's do the first aspect, putting it straight into the function. So f of 4 will be equal to what? 2 times 4 cubed minus 5 times 4. So we are just putting in the value 4 into the function. So it's not something difficult. So minus 12. Yes. And this place it will give us what? 128 minus 80 plus 12. Then we have 48 plus 12. 48 plus 12, and the answer is what? 60. Now this 60, so f of 4 is what? 60. So this 60 becomes what? Our remainder. Alright, so this is quite simple. So we can also make use of the synthetic method to find the remainder here. So you see we had 60 here. Let's use the synthetic method to find out how true that one is. So our next aspect, using the synthetic method. Now, what will be our C? Yes, I told you that it is basically about substituting the C into the function straight. So in this case, when we are dividing, our C was what? It's going to be 4. Now the function given, what are the coefficients? We have 2, -5, 6, and -12. Now we bring down the first coefficient, which is 2. 2 times 4 will give us what? 8. Then you write it here, you add, and that will give you what? 3. You use 3 to multiply 4, you get what? 12. Then you add, you get 18. You use 18 to multiply 4, you get what? 7, 2. Then you add, you get what? 60. And this is our remainder. That's the same thing that we had here. Yes. So the synthetic method is also possible when it comes to the remainder theorem. Alright, let's take another example. We have a function, so our example 2. We have a function f of x being equal to 3x exponent 4 minus 7x exponent 3 minus 9x plus 12. We have to find f of 5. Alright, so using the synthetic division, what will be our answer? Alright, now our C is what? 5. This is our C. So our C is 5. So as I said earlier, if you have a function like this divided by something like this, it should be equal to f of c. So it's just like substituting the c into it. So this is our c. So if you are given f of 5, meaning that our c is equal to what? 5. Alright, so we have this 5 here. What are the coefficients? So we are going to get 3, negative 7, negative. Okay, so 3. Before that, we are supposed to get something like 0x squared before the x. So we have what? 0 here. Then before negative 9. Then we have 12. Alright, so let's see. You bring down the first coefficient. You use it to multiply the c. So 5 times 3 will give us 15. Then we add, we get what? 8. So we add in column. Alright, 8 times 5 will give you 40. So 40. You add, you get what? 40. Now 40 times 5 will give you what? 40 times 5 will give you 200. Then you add, you get 191. 191 times 5 will give you what? 955. Then you add, you get what? 967. So it means that our remainder R is what? 967. So this is our remainder. Yes. So this is quite simple. You can confirm this by substituting this value here, the 5 into it straight. Then you get your answer. Alright. So that is that. Thank you for watching. Welcome to Math Tutorials, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, you are in the right place. Let's dive into today's lesson, but please don't forget to subscribe for more videos. Alright, so today our focus is going to be on factor theorem. Factor theorem. Factor theorem. Okay, so what is it all about? Factor of a polynomial. Let's say you have something like f of c being equal to 0. So let's say you are given a polynomial, then you substitute the value of c into it, then you are getting 0. It means that x minus c is a factor of f of x. Yes, so if you put this c into it, then you are getting 0. It means that x minus c is a factor of that polynomial. And the reverse is true too. If x minus c is a factor, then f of x is equal to 0. That's the reverse. So the first one, if you have f of c being equal to 0, then x minus c is a factor. Also, if x minus c is a factor, then f of x is equal to 0. Sorry, this should what? F of c. So f of c should be equal to what? 0. Alright, so that's all, or the basic idea behind the factor theorem. So if you have a 0 of a polynomial, you put it into the polynomial, you are getting 0, meaning that that value is a 0 of that particular polynomial. Or if you take a linear divisor, you divide it, and you are getting a remainder to be 0, then that particular divisor is what? A factor of that polynomial. Alright, let's take an example on that. Example, solve the equation. We have to solve the equation 3 exponent x minus 4x squared plus x plus 6 equals 0. Given that 3 is a 0 of f of x. Alright, so what is the basic idea behind this? So since 3 is a 0 of that polynomial, then we can have x minus 3 is a factor. So it is in the form x minus c. So if c here is a 0 of that polynomial, then x minus c is a factor. So it means that if it is a factor, when we use this to divide this, we are supposed to get the remainder to be what? 0. So let's find out by using the synthetic method. Alright. So it means that we have our c to be what? Yes, it's 3. Then we write our coefficient 1, -4, 1, and what? 6. We bring down the first coefficient, we use it to multiply c, we are getting 3. You add, you get -1. -1 times 3 will be what? -3. Then you add again, you get -2. -2 times 3 will get -6. You add, you get what? 0. So something like x cubed minus divided by x, we are going to get x squared. So our first part will be what? X squared minus x minus 2. The remainder is 0. Yes, it has truly confirmed that this one here is a factor of that polynomial, since you are getting the remainder to be 0. Okay, now let's continue. Basically, when we have the polynomial, this is a polynomial. We have x cubed minus 4x squared plus x plus 6. We divided it by the factor x minus 3, and we are getting x squared minus x minus 2. Now, it means that when we take this one, x minus 3 times x squared minus x minus 2, it should give us the polynomial back. It should give us this. Yes. Now, we have to find the zeros. Already we know the zeros. The first one given, it was what? 3. Now let's find out for this one too. So factoring this part alone, the x squared minus x minus 2. Now, to do this, let's compare this one, this in a quadratic form, compared to a general quadratic expression. Yes, so ax squared plus bx plus c. So to factor this, we multiply a by c. Now, so from here, comparing, our a is 1, b is -1, and c is -2. So a times c, so we have 1 times -2, giving us what? -2. So we are going to look for two numbers that when we multiply them, we are going to get -2, but when you add them, we get our -1. So which numbers are these numbers? Okay, when we take -1, or when we take -2 and 1, you see that -1 times -2 will give you -2. But when you add them, -1 plus -2, this is going to give us what? -1. So we can use these two numbers. So we are going to write this in the form. So we have x squared. So this is now going to be in the form x squared minus, so we had 1 and negative 2. So x minus 2x then minus 2. This one here, you see that when I subtract, I'm going to get my negative x back. Yes. Now, considering the first two terms, we can factor x out. X out, x plus 1. The next one, we have 2 out, x plus 1. So we are able to get x minus, we are grouping the 1 outside the bracket. Then we take one of this, so x plus 1. Okay. Now, since the polynomial stated that polynomial was equal to 0, so it means we are going to equate this one to what? 0. So x minus 2 is equal to 0, and also x plus 1 is equal to 0. So our x is equal to 2, or x is equal to what? Negative 1. Now the zeros of that particular polynomial will be, so the zeros will be what? 3, 2, and negative 1. What are these zeros? Now we said that these zeros, when you substitute them into the polynomial, all of these ones, it will be equal to 0. The result will be 0. So since they are zeros, means that when you substitute them into the polynomial, we are going to get exactly what? 0. Yes. So that's how the polynomial, that aspect is. Okay. Thank you for watching.